Hey guys, welcome back to another video. This is actually going to be the lecture today. Let me get it started. We're going to talk about data modeling and entity relationship model. And before we get started, I wanted to take you out to, you guys know about the tutorial site. Go down to databases under video tutorials. This will be helpful for this course. And once you open it up, or for this week, come down to how to create a data model. I take you through, I think it's about it's 11-minute video. I'll walk you through how to set up a data model from beginning to scratch. I think it'll be very helpful to watch that video. It'll tie into what we're talking about here today. All right, so objectives are to learn basic stages of database development, understand the purpose and role of a data model, know the principal components of ER data model, understand how to interpret a traditional ER diagram, understand how to interpret information engineering models, crews for ER diagrams. These are just how the model communicates with each entity, each table. Learn about constructed ER diagrams. Know the the relationships. Understand two types of weak entities and how they use them. Understanding non-identifying and identifying relationships, how to represent a subtype, and so forth. So let's get started. Sorry, drinking some water. I have been talking all day. The three stages of database developments are requirements analysis, component design, and implementation. So what does that mean? So let's say that you're working on a project for work, and you could be running different methodologies. The most common methodology today is either waterfall or agile. Think of waterfall if you've ever heard of it. Waterfall is, I like to say it's a longer process, and it's a process that takes a period of time to complete the task because you have multiple players and stakeholders. So you're multiple people involved. You have a project manager, you have a business analyst, you have software developers, you have QA developers, and sometimes you'll have like your client. Then your stakeholders would be like your client. Those are people, these main people involved. And then agile is a process that takes, it could be something, they call them in sprints. You'll do a small amount of work within a 2-week period. Sometimes some people do 4-week periods, but the nature of the game is to do a 2-week sprint. And there's all these special meetings that you come with it. But in either way, whether you're doing agile or waterfall, it's very important that you have a requirements analysis. It's important that you put the requirements together and understand what the problem is. So let's say hypothetically a company comes to us and says, hey, we want you to develop a back-end database to support our new application. It's our new cloud-based app that's going to be the biggest thing ever. Okay, so you as an analysis person, you need to identify, okay, how's the app going to work? Who's going to be involved? All this stuff. That's important. The component design aspect of it is after you've analyzed the app, what it's going to look like, how it's going to work, who's going to be involved, then that's when your developers or your architects, depending on the nature of your business, will design what the screens are going to look like. What's this screen going to look like? What's it going to look like after this, and so forth. Then your implementation is overall the last step that happens. What is your plan on how you're going to implement it to production or to this environment? You have to have a plan together. So these three stages are part of 5-stage system software development lifecycle model. So see online, getting started with the system analysis. So sources of requirements of a database application are user interviews. So you need to interview and see how's this going to work. There's forms, reports, queries, querying information, getting data, application programs, what are programs running, websites, use cases, and business rules. And business rules are always important because you could have 75, 85. I give an example. The last application I was involved with had 3,500 business rules. Imagine that. but those things happen. Entity class is a collection of entities and provides the structure of entities in the class. Well, that means nothing. That's a lot of something. So the entity class is it's like your attributes. So let's say that you have a table, and your table is called people. And what goes with that table? What are your attributes? Well, maybe first name, last name, something specific about that person. Maybe their city, state, zip. That would be your entity class. An entity instance is an occurrence of a particular entity. So it might be something that ties to that. So you have the person, and then you might have another entity class that consists of detailed information. Maybe that person's vehicle, what type of vehicle they drive, what's the year, make, model, etc. That might be an instance of it. So in this example right here, what they're using is they have two entities, and they have an item entity and two entity instances. I can't even talk. So in this example here, they have item number, description, cost, price, and the classes are your attribute values. So maybe you're getting one from 1100, one from 2000. This is just data that is in, when they say instant, going back to this, when they go to classes or instance class, all they're saying is a row. So if you go to like Microsoft Excel and you enter a row in, row 1 is entity class, row 2, and so forth. Now I mentioned that it ties into the attribute because this right here is the attribute, this is the class, and these are the values. Okay, these are two instances, but you're going to have multiple instances. So hopefully that makes sense. So entities have attributes, which are these guys right here. These attributes have a description. What type of data type are they? Are they, in this case, are they integer? Are they a money, a double? Are they a string, a variable, and so forth, or varchar? So entities, which describes the characteristics such as employee name, date of hire, job scale. Same thing right here. Entity instances and identifiers. Identifiers is an attribute that names and identifies instances, such as below. Uniqueness. Identifiers may be unique or non-unique. So if the identifier is unique, the data value for that identifier must be unique for all instances. So think of a unique value. So what do you think about what's unique? Think about yourself. What's unique that you have that no one else has? I give you a couple seconds. Social Security number. There should be no possible way that we all have the same Social Security number. That's unique. Driver license ID. That's a unique ID value as well. So when you're setting up a database table, you want to come up with a unique value. And sometimes you have a non-unique value. And we'll talk about what that is. A composite it identifies it consists of two or more attributes. So what this means is, let's say that you have some type of uniqueness about that table. And if you use the composite, that means that you're going to have multiple attributes that tie into each other that makes that table unique. So what you're saying is, oh, okay, it takes employee number, line number, and we'll say date added, which is not here. But we'll make that up and say these three fields are unique. And that's what makes it unique. And that right there is a composite. All right, so entities can be associated with one another in relationships. The number of entity classes in a relationship is known as a degree of a relationship as follows. So degree 2 is a binary, and 3 is a... the thing is, we're not really going to get into these relationships. Really. But it's showing you here how this is the binary, and it's a ternary where you could have a mother and father that tie into it versus how this is. You couldn't have multiple. Locker assignment, this is a 1-to-1, so it's showing you what a one-to-one relationship looks like. This right here, a one-to-one relationship means that there's only one value that matches it. It doesn't have multiple values. Where this one here has one-to-many relationships, which means it can have many values related to this item here. And this one right here has many-to-many relationships. Means that this item or supplier or whatever can be on multiple attributes. It can have multiple different values. So hopefully, and if you have questions about this, please Slack me or email me. Relationships are named and classified by their cardinality, which is a word that means count. Count means number. How many do you have? Each of these three types shown in the previous slide have different maximum cardinalities, and the maximum number of the entity instances may participate in a relationship instance, one, many, or a fixed number. Okay, so the minimum number of instances must participate in the partnership instance. And these values typically assume the value of 0 optionally or mandatory. So this talks about, I'm going to kind of skip this. This is irrelevant to what we're looking at right now. I'm just kind of skipping that, irrelevant. I'll let you read about, well, let's talk about this. So information engineering, James Martin, 1990, his crow's feet to show the many sides of a relationship is sometimes called crow's foot model. And it's just what it looks like. Integrated definition 1 extended. This is a version of the ER model that is notionally standard. The UML is a set of structures and techniques for modeling and designing object-oriented programs. So this is very commonly used. I know that in my past, when I was developing how a environment works, I used UML, and it's a very common language to use. And it's not a programming language; it's just a design model approach. And this would kind of be like almost like in UML. This right here, I would definitely study these. These are different symbols, so that when you're creating a relationship between two instances, you want to understand what it means. So this right here, the symbol is for one. This is for many, the crow's feet. This one right here looks like a cross on a circle, optional 1. And this one right here is optional many. So I would definitely study those. And as you can see, if you look at the design here, like this guy right here has that right there, and you're like, okay, that's a many relationships. And then you come over here, you're like, oh, okay, I got the same one. But then when you look at this one, this is optional 1, and that's right here. So that will be very helpful. Weak entity, what is it? It cannot exist in a database without an existence of another entity. So any entity that is not a weak entity is called a strong entity. Let's see here. Some of this stuff I will skip because it's irrelevant to what we're learning in the course. All right. This right here is a good example. It shows you how to set up a relationship. So what relationship is this? This one has many relations. This has one. So it shows you how the tables are set up. So if we go back to our identifier here, that's our, we've seen many and we've seen optional 1 there, I believe. Yep. So this has many values that are associated with this. The same thing with this. So, you know, when they tie together, there could be multiple values. It's not just, or many different relationships. So you might just have, you might not have just one attribute linked into this. You might have multiple attributes. You may have a multiple foreign key relations. Okay. The relationship between a strong and weak entity is termed as the identifying relationship. So if the weak entity represents the solid line, etc. Skipping that right there. I'm going to let you read through this, watch this video. This talks about the strong and weak entities. This talks about the associative entity. It's used when you do a non-the-many relationship that cannot properly hold attributes. This right here just gives you a little bit more of a description. And this is key to have this build this functionality. What's very important in having a data model is being able to keep track of your environment. So one of the important things is, let's say that you have an environment that's out in production, and anytime that you get changes, you want to have your data model up to date. So that way, if there's ever a problem, you have the most recent updated data model, plus it's best practice if you're in that industry. Let's skip that. Some of this I'm just skipping. This is actually pretty good, but I'm skipping that. Developing the ER diagram. So I would definitely suggest watching my 12-minute video showing you how to set up your own diagram. I'm not going to go through that because that's related to the assignment. Gonna miss this. All right, business rules. So business rules are data values and processing from a database. So in this case, it's looking for something specific. So maybe it has a business rule that says anytime that we receive a value of, let's say money, for example, anytime that there is money exceeding $1,000, then we must move all that data, all those instances over to another table. So that would be a business rule, or maybe you stage it somewhere else. You don't want it to be in your primary area for whatever reason. So business rules are pretty much anything that you want to seclude, you want to add on to. You might have a rule that says, oh, if I receive this, like for example, the money values, maybe you want to add a dollar sign, you want to convert the field to a different data type, etc. It could be anything. Prototyping is commonly used to validate forms and reports. And that's it right there. I mean, that's a quick 16-minute video, which seemed like 5 minutes. Anyways, that's pretty much it for that week. The other things to kind of go over this week is introduction. Here's your objectives for the week. You're learning. Make sure you do your quiz. Make sure you do your summary. There's a quiz I mentioned. The discussion number 4 is, now that we have a good feel for what a database is and how to use them, we're going to turn to designing a database. The design of a database is done in 2 steps: data modeling and then the actual database design. So data modeling is a topic for this module. Database design is a topic for the next module, and so forth. So read through this. This is actually pretty good information. I think it'll be helpful. Let's see here. We have the assignment, which is Highline University. So read that in the book. And there's some more further stories. And then right here is the data model. So you can watch it here. If you haven't, it won't let me connect. So I would recommend to go out to the IT tutorials for sure. All right, well, that's it for this video. Thanks for watching this week, and good luck and have a great week. Bye.